let's start with, let's say, for example, you go into a bank with $1,000. And your account gives 10% interest each year. Okay, you would never get 10%. This is super, super high. I'm using it because it's a nice, easy number, and I want you to, be really, I want this to be simple. Okay, simple numbers. So you go into a bank with $1,000, and your account gives 10% interest per year. The way that this works is, let's say that you go in on January 1st, you put $1,000 into the account. January 1st the next year, it looks at what you have in the account and it says, okay, let's take 10% of that and add it to the $1,000. Okay, so what we're saying is January 1st, 2020, let's say, you have $1,000 in your account. Okay, now we're going to look at how much you have in your account on January 1st, 2021. Well, we're going to take 10% of $1,000. And the way that we take 10% of $1,000 is we multiply by 0.10. So we're going to do $1,000 plus 10% of $1,000. So this 0.10 times 1,000 is 10% of 1,000. And this is money that just gets added into your account. You didn't do anything to earn it other than put it into the bank. Okay. Now what we're going to do here, and you're going to understand why we do this in a little bit, but if you notice, both terms have a 1,000 in common. So we're actually going to just factor that out. If we factor out the 1,000, then we get 1 plus 0.10. Okay. Well, if we take 1,000 and we multiply by 1 plus 0.10, that's going to give us how much we have in the account at the end of the year. And it tells us that we have $1,100 in the account. Okay. Now this 1 represents like 100%. This says take 100% of what we have and add 10% to that. Okay? So this tells us that on January 1st, 2021, we have $1,100. Now this is assuming we are not withdrawing or depositing. We're keeping this simple. Okay, now let's see how much we have on January 1st, 2022. Well, we can write this as $1,100 now. And then we're going to take 10% of 1,100. Okay, well what we can do is we can factor out 1,100, just like we did before, right? So here's the $1,100 that we had, and we're adding 10% of that. But we could factor it out. Here's the thing though. This 1,100 is equivalent to this, right? This we know is 1,100. So we can just do substitution. we're going to replace 1100 with this. And again, you'll see why in a second. If we do this, then what we get is instead 1000 times 1 plus 0.10 times 1 plus 0.10 again. So we just substituted here. This that I'm boxing right now is $1,100, so it's the same thing, right? All we did is we replaced the 1100 with this here. And the reason why we're doing that is you can see that we're taking the original amount and we're multiplying by 1 plus 0.10 twice. Now we have something exponential. So after the second year, we don't have to calculate this all the time. This is the same thing as 1 plus 0.10 squared. And you can see it's the same. 1100 times 1 plus 0.10 is 1210. But if instead we did 1000 times 1 plus 0.10, sorry, I messed that up somewhere. And we're going to square that. Okay. Well, what does that equal? 1210. It's the same thing. Okay. It's the same thing as doing 1100 times 1 plus 0.10. Now we have $1,210. Okay, let's do this one more time for January 1st, 2023. So we already know that we could factor out a 1210, right? We're saying take $1,210 and add it to 10% of that. This 1 represents the 1210. If we redistribute the 1210 in, we have 1210 plus 0.10 times 1210, okay? But this 1210 is really the same as this right here. This is 1210. So we're going to replace that 1210 with 1000 times 1 plus 0.10 times 1 plus 0.10 and then times the 1 plus 0.10 that we had before. So this part is 1210. So times 1 plus 0.10. And what we're saying is that this is really 1000 times 1 plus 0.10 to the third. And if we do that here, I keep doing the same thing. I keep forgetting to write times. This time we're going to raise it to the third power. The cube means raising it to the third, remember. And we get $1,331. And that would be the same as doing 1210 times 1.1. Or 1 plus 0.1, which is 1.1. So you get the same thing. So what this means this would be after 1 year. This would be after 2 years. And this would be after 3 years. So if we want to know how much we have after 10 years, we don't have to figure out how much we have in the 9th year, right? If we had to figure out how much we had in the 9th year, then we would have trouble because we would have to do this 9 times over. We would have to know this. But what this is, hey, you only need to know what you had when you originally put the money in. So we know that after the 10th year, we have $1,000 times 1 plus 0.1, and we've been doing this 10 times now. And if we do that, we're going to raise this to the 10th. So on your calculators, you see this x to the y? That's an exponent. It's saying, okay, let's put in a caret, which represents exponent, and this is to the 10th. And this is saying, okay, so we have $2,593, and this is dollars and cents, so we round to the nearest hundredth. $0.74 after 10 years. So we've more than doubled our money, but remember, we have a huge interest rate here. And if we want to know, okay, well, how much do we have after 20 years? Well, again, we could figure this out. Just by doing 1,000 times 1 plus 0.10 to the 20. And if we do that, we're going to use this x to the y again. We get $6,727.50. So we're rounding to the nearest hundredth. Okay? So let's come up with a general formula. This is going to be our first formula. We have 3. Okay? So our first formula is P equals P0, 1 plus R to the T. Okay, let's define what this means. P0 is your original investment. Your APR. APR is annual percentage rate. So when we say 10% interest, we're saying APR of 10%. But our R has to be written as a decimal. Okay, when we plug in, we're plugging in 0.10. And then our T is time. This is almost always in years. Okay, and our P is what we have after T amount of time. So this is our first formula. Here's the thing though. This says that we give you the full 10% at the end of the year. But as a bank, we may not do that. We might actually break it up and give you instead half your interest in the middle of the year after 6 months, and then the other half after the next 6 months. Okay, so let's take that instance. So we don't usually say it like this. What we're really saying is you go into a bank to invest $1,000. With an APR of 10%, compounded semi-annually. So semi-annually is twice per year. Right? 6 months, every 6 months. Compounded is just a fancy way of saying collect interest. So you're getting 10% over the course of the year, but you're getting it twice. You're getting half of it after the first 6 months, half of it after the second 6 months. If we said compounded 4 times per year, it would be saying you're getting a quarter of it after the first 3 months, the second quarter after the next 3 months, the third quarter after the next 3 months, and finally the last quarter over the next 3 months. Okay, so that over the course of the year, you've gotten a total of 10%, but 2.5% each time. Okay, so the number of times that you compound is the number of times that you collect interest. So we're going to do the same type of thing, same amount of money, same annual percentage rate, but we're going to look at how much we have after a year in this case. So in this case, instead of after 1 year, we're going to do after 6 months. Okay, so after 6 months, we're going to get $1,000 plus $1,000, and this time, instead of multiplying by 0.10, we're only multiplying by 0.05. So this is your R divided by 2. Right? We're really only getting 5% here. We're taking the R and we're dividing by N because it's telling us that we're compounding semi-annually. So we're collecting twice per year. So each time we're only getting half. Okay? So the same way that we did it before, we can factor out the 1,000. And if we go and do that, this is 1,000 times 1.05. And we get $1,050 after 6 months. Okay, now let's see what we get after 1 year. Well, after 1 year, we're going to get the 1050, which is the 1,000 times 1 plus 0.05. So we have 1,050 plus 1,050 times 0.05. Now we already know what's going to happen here. We can factor out the 1,050. And we know that the 1,050 this here. This is what's allowing us to use the exponents. So we're going to plug in. What that means is that we could figure this out just using the 1050. Right? We just substituted. This was the 1050. So this is really, I'm breaking this up for you a lot here, just so that you see where this is all coming from. $1.05 squared. And if we do that, what this is saying is after 1 year, one plus 0.05 is 1.05. Well, now we have $1,102.50. Well, this is more than we had before. We only had $1,100. Here we have more. So we have more here. So that's actually a huge thing. Why that's happening. It's happening because we're not collecting the interest. We're not collecting the 5% on $1,000. The second 6 months, we're collecting 5% on $1,050. So we're collecting extra that we didn't have before. In the other case, it would be as if we collected 5% on 1,000 and then 5% on 1,000 again. Here we're not. We're collecting 5% on 1,000 in the beginning. But then we're collecting the second 5%, not on 1,000, but on 1,050. Okay? So this is because we are collecting interest on interest. So the question is, why would the bank do this? And the bank actually does do this. It gives you interest more often. So here's why the bank does this. Now, if you don't withdraw at all throughout the year, then you get more money, okay? Because you're collecting interest on interest. But let's say, for instance, that you start off with $1,000 and then you withdraw $500 in June, and then you put it back in December. Well, when the bank gives you money after a year, okay, it only looks at what you have on December 31st, okay? It doesn't look at what's happened in your account up until then. So the fact that you withdrew the $500 and you only had $500 in your account for half the year, it doesn't matter, okay? Because you're still going to collect that amount of money. You're still going to collect interest on the full 1,000 because that's what you had at the very end. If it collects more times per year, if you don't withdraw any money, then it's a benefit to you. But if you do, let's say that you have $1,000 and in March you withdraw $500, and then you redeposit that $500 in November. Well, if it collected once per year, it's giving you the full 10% on $1,000. But if you're collecting interest twice, well, you withdrew $500 in March. So that means on June 1st, when the bank gives you interest, they're only giving you interest on $500. They don't have to give you your 5% on 1,000. They're giving you 5% on what you have. So now you're actually getting less because you're only getting 5% on $500. So it's a benefit to them if you're withdrawing. It's a benefit to you if you're depositing, okay? Or if you're not touching your money. So the way that the bank feels is it makes you feel better if they give you interest more often, because it's going to make you feel like you're collecting interest on interest. And for the people who are kind of depositing versus withdrawing, it balances out. It all balances out throughout the year, okay? Because some years you're going to deposit, some years you're going to withdraw. So it's kind of a psychological thing. It says it makes you feel like you're getting more money, but for them, it all balances out in the end. Okay, so now we have a second formula, and the second formula has to do with whether or not it's compounding, whether or not you're collecting more interest. So let's write down our next formula. So it's very similar. And this one is P equals P0, right? We have our principal. The P0 is the original investment. I'll put this in up here too. It's also, we can call it the principal amount. That's the original amount that it is. So we have P0, and then instead of 1 plus R, every time that we do this, we're doing 1 plus R, and we're dividing by the number of times that we compound. So if we're compounding twice, then we're gonna take our APR and we're gonna divide by 2. If we're compounding 4 times, we're going to take our APR and we're going to divide by 4. If we're compounding 10 times, we're going to divide our APR by 10, okay? And then instead of just multiplying by T, we're going to actually take T and we're going to multiply it by N. So our exponent isn't just T, it's NT, okay? And it's NT because you can see that at the end of the year, you've collected interest twice. At the end of 2 years, you will have collected interest 4 times because you're doing it 2 times per year. At the end of 10 years, you're collecting it 20 times because each year you're collecting it twice. So you would multiply the number of years by 2. Okay, so let's write this down, what each thing represents, just like before. So this original investment, I'm going to add it up here too. It's referred to the principal amount. So P0 is the same thing. Principal amount or original investment. I switched this, that's because it means the same thing. Your R is still your APR is a decimal. Typical mistake is that people don't plug it in as a decimal. Okay, you're gonna know that it's a mistake because your final number would be huge. If you plugged in 5 instead of 0.05, this number would probably be in the 100,000s, which wouldn't make any sense at all. Okay, and your N is the number of times you compound per year. Which means R over N is the amount of interest you get each time you compound. Now you don't actually have to remember both formulas because in this formula, what we're doing is we're saying you're compounding once per year. Well, if N is equal to 1, R over N is just R. And if N is equal to 1 here, 1 times T is just equal to T. So this formula includes this one, okay? So just a couple of things. Just in terms of terminology. Compounding semi-annually just means that N is 2. If you see that it's compounding quarterly, then your n is equal to 4. If it's saying it's compounding monthly, then you know that your n is equal to 12. If it says weekly, your n is equal to 52. And if it says daily, then you would use 365. Okay. So we have one more formula. And that last formula is if you compound continuously. So compounding continuously means that you're compounding an infinite number of times, which again, for the bank is good because it kind of balances everything out, okay? So if you compound continuously, you're compounding an infinite number of times per year. Which means you need a new formula. You can't use the formula that you had. Because you can't plug in infinity into that formula. Derive that formula, okay? And the way that we're going to derive it is we're going to take out the interest rate, we're going to take out the n, and we're going to take out the t, and we're just going to look at a small part of the formula, okay? And this is our last formula. Look at this 1 plus 1 over n to the n, okay? So we're going to create a table. And we're just going to plug in different values for n. So if we plug in 1 for n, and we plug that in over here, 1 over 1 is 1. So 1 plus 1 is 2, and 2 to the first is 2. So we get 2. If we then plug in a larger number, okay, so remember n is infinity, n is a huge number, so that's what we're doing, we're plugging in a huge number. So if we plug in 1,000, we actually get 2.716923932. Now we're going to plug in an even bigger number, we're going to plug in 10,000. And what we get here is 2.7118145927. Now we're going to plug in 1,000,000. And if we plug in 1,000,000, we get 2.7182804669. If we plug in 1 billion, that was not 1,000,000. I got overexcited there. That's 1,000,000. If we plug in 1 billion, we also get 2.7182804669. So notice what's happening. As we plug in larger and larger numbers, this becomes the same. This approaches the same number. This is because this gets really, really, really tiny. So 1 plus this, it's not making much of a difference. 1 plus a really, really tiny number isn't that different from 1 plus a really, really, really tiny number. So what's happening is we approach a special number. Some of you have heard of this number. It's E. And E is 2.718280469. And E is on your calculator, okay? Sorry, I said 2.7188. I should change this. Two 8. 1 8 2 8 and so forth. Okay, it's an irrational number. It's like pi. It has a value. If you remember, we said E is not a variable that we typically use. Okay, and this is why, because E has a value. So this means that we have one last formula, and you only use this formula when it says compounding continuously. This time, 1 plus 1 over n to the n becomes E, and the r actually moves into the exponent. So now we have essentially two formulas, because remember, we don't have to use this formula here. We're really only using this one when n is equal to 1. That's what this is. So I can even add in here annually n is equal to 1. And then we're using two formulas, okay? Okay, so let's just do a couple of examples and then we're done with this for today. So let's say, for example, you invest $23,000 with an APR of 2%, compounded 3 times per year. And the question would be, how much do you have after a certain number of years? So let's say, how much do you have after 7 years? Okay. Well, this is a plug and chug, okay? It's not compounded continuously, which means you're not going to use the formula that we just did. You're going to use the other formula. You're using this one. P0 equals 1 plus r over n to the nt. Your r is 0.02. Remember, it's as a decimal. Your P0 is 23,000, because that's your original amount. Your N is 3. It's compounding 3 times per year. And your T is 7. So this is a plug and chug. You're just plugging it in here. So your P is 23,000 times 1 plus 0.02 divided by 3. Every time you get interest, you're getting a 1/3 of 2%. And then it's 3 times 7. Over 7 years, you're collecting interest 21 times. So let's go to our calculator. Now do this slowly. I'm going to do it, and then you're going to do it in the same way. So you're going to do 0.02 divided by 3 first. This gives you this number. It should be a small decimal. You're going to add it to the 1. The 1 represents 100% of what you have. Okay, so now you have 1.0067. You are going to raise this to the 21st power. So you're doing this order of operations. Parentheses first. Inside the parentheses, we have division. Division comes first. Then you add. Then exponents after parentheses. So we raised it to the 21st power. That's 3 times 7. And now we're multiplying by the 23,000. And this tells us that we have 26,444, and it's dollars and cents. So you round to the nearest hundredth. Okay? You will always round to the nearest hundredths. And that's it. It's a plug and chug. Let's take another one. Suppose you invest $8,000 with an APR of 0.5%, compounded continuously. So notice you don't have an N here. You want to know how much you have after 10 years. Okay, so in this one, it's compounded continuously. As soon as you see these words, you're using that second formula. You're using the one with E. And here your R is 0.005. It's as a decimal, so you move it, you divide by 100, okay? You're moving your decimal point two places to the left. Your T here, you want to know how much you have after 10 years. And your P0 is 8,000. So now we just plug in. It's a plug and chug. You just have to figure out which formula to use. Compounded continuously says you use the formula with E. Compounded any other amount, so here it's not compounded continuously. Any other case, you're using this formula, okay? So here, we're doing P equals 8,000 times E to the 0.005 times 10. Make sure you plug it in as a decimal. So you're going to do order of operations, okay? You have to first figure out what your exponent is. So 0.005 times 10 is 0.05. Now you're going to do E raised to that power. So here's your E. You're raising it to the 0.05. Now you multiply that by your 8,000. And notice you don't make that much money, okay? You're not going to make that much money. It's a very small I mean, $400 is nothing to sneeze about, but it's not as much money as in some of these other problems that we've done. Okay. So it's $8,410.17. Do dollars and cents. Okay. Let's do another one. We'll do 2 more, just so that you make sure that you got the hang of it. At this point, you should pause the video and do it on your own. So I'm going to leave out some of these words. You invest $12,000. Your APR is equal to 0.25% compounded monthly. How much? After 16 years. So this is a place where you might want to pause the video, do it on your own first, and then start the video again and see how we work through it. So this doesn't say compounded continuously, which means that we're using this equation up here. So our R is 0.0025. Remember to divide by 100. Our N is monthly, so our N is 12. Our T is 16. Because we want to know how much we have after 16 years. And our P0 is 12,000. So again, it's a plug and chug. We're doing 12,000 times 1 plus 0.0025 over 12 to the 12 times 16. So now we go to our calculator. We're going to do 12. We're going to do parentheses first. 0.0025 divided by 12. Then we're going to take that and add it to 1. Now we're going to raise that to the power of 12 times 16. So you have to put the 12 times 16 in parentheses. Otherwise, it's just going to raise it to the 12th first, and then it'll multiply by 16. So this 12 times 16 has to go in parentheses. And then notice you just get a number a little bit above 1. That's the way it should be, okay? If you got something much above 1, then you did something wrong. And then we're going to multiply by 12,000. And it makes sense that we wouldn't get such a high number because our interest rate is so low. So it's $12,489.68. Okay, and finally, last one. So you invest, let's say $25,000 with an APR of 3%. Maybe you have a CD. CDs can go as high as 3%. Compound it continuously. You want to know how much after 8 years, say? Okay, again, consider pausing the video. So in this case, we see compounded continuously. That's the word that will be used. So we're going to be using P equals P0, E to the RT. Our R is 0.03. Our T here is 8. And our P0 is 25,000. So we just plug and chug. P is 25,000. E to the 0.03 times 8. So we're going to do the 0.03 times 8 first, so that we know what the exponent is. You can do E and then to the power of, and then put the 0.03 times 8 in parentheses. That would be fine too. So actually, if we did that, it would look like this. E to the power of, in parentheses, 0.03 times 8. Okay, and you see the 0.24, that's telling you what the 0.03 times 8 is. And we get a number that's above 1. Okay, it's not much above 1, it's a little bit above 1. And we multiply by 25,000. And we get 31,000, so it's a higher interest rate, which is why we have a higher amount. $31,781.20. I wrote 28, but I meant 23. Just to give you an idea, so don't write this down if you're doing any writing. If we did E to the power of, and instead of doing 0.03, we did 3 times 8, this is the difference. You see how we get this huge, huge number? It's not just a little bit above 1. It's like 26 billion, okay? And then we multiply by our 25,000. This doesn't make sense that we get 3% interest and we're doing this. What this is telling us is that we're getting 30% interest. Even if you did E to the power of 0.3 times 8. Even here, you get a number 11. You should just get a number above 1, okay? If the interest is really high, maybe it'll be a number above 2, but it certainly won't be as high as 11, okay? And you can see that even if you multiply this by 25,000, you get this huge number. There's no way that you're gonna have 275,000. So at the end, just make sure that your answer is reasonable, okay? So just small notes, just to finish us off. I know that this is a very long video, so just to finish this off. If, let's say, where it's really one note that I'm going to leave you on. APR is the annual percentage interest, right? But the APR in this case is 10%, but we're actually getting a little bit more than 10%, right? We're actually getting 10.25%, I think it is. So we're actually getting a little bit more. That we refer to as the APY. So the APY is the annual percentage yield, and it's the actual interest that we get, including the amount of times that we compound. Okay, taking that into consideration. So I'm gonna put this here just as an extra note. Just because when you go into a bank and you get their brochures or you look on their websites, sometimes instead of seeing APR, you'll see APY. And I just want you to understand that it's the actual interest that you're getting, taking into account the number of times that it's compounding. Most of the time, the interest rate is so low that the APY and the APR is actually the same. But the APY otherwise will always be higher than the APR. Okay, because you're always getting a little bit more if you're compounding more times per year. And then it's probably worth mentioning that if you're talking about things like half-life, it's a little bit different. Your half-life, you would be taking your original amount and you would be multiplying by 1/2 instead of E, because every day it decreases by 1/2. So that's probably worth just mentioning. But we're not actually going to be looking at that so much, so I'm not going to write it down or even do any problems with it. But this is essentially what you need to know